Hello students. Today actually we are going to discuss about the testing methodologies. That is the unit 4 of your syllabus that we are going to start. So when we test the software system, basically why do we test the system? What is the reason of testing? Okay. We test because the systems are fallible, because the systems may show some bugs. Okay. So to find out those bugs so that the system becomes acceptable to the users. So we basically we test the system. We develop the test cases to test the systems. So it is basically we have these main two reasons for which we test the systems to make judgment about the quality of the software. So quality comes when the softwares are basically error-free, right? So it is, and also the acceptability. It should be usable to the system, to the users. Okay, it should be liked by the users. So we test because we want to discover the problems. So such a arising problem is always for the software systems. Is always there. That is we are always likely to create make some mistakes, and because of those mistakes there is always likely to be some bugs in the system. So our objective is to test the system properly. So before going into the detail of how the test cases are developed and the testing is done, let us see some basic definitions. Okay. So first definition that we are going to see is the error. So error, when we say error, the people always are likely to commit some error, or we can say the good synonym of the error is a mistake. Okay, because when we do something, we are likely to commit some mistake somewhere. So when people make mistake, we call those mistakes as the bugs. Okay. So these errors, mistakes which we do while developing the system in different phases, they are likely to propagate phase to the other phase. That is, from suppose the requirement analysis, if we do some mistake there, it may be magnified in the design phase, or it can again be amplified further during the coding phase. Okay. So error normally propagates from one phase to the other phase. So another definition is about the fault. Okay. So fault is the result of an error. So when we create some mistake, we are going to include some fault, or a good synonym for the fault is actually a bug. Okay. It is more precise to say that the fault is representation of an error, okay, where the representation is the mode of expression. So such as, when we say mode of expression, it may be a narrative text, it may be a data flow diagram, okay, hierarchy chart, source code, etc. So we may call a fault, a synonym of fault, something like a defect or a bug. Okay. Now fouls can be of two types. One is where a foul can be of fault of commission or fault of omission. So the fault of commission occurs when we enter something incorrectly. Okay, some representation incorrectly. Then we call it the fault of commission. Fault of omission occurs when we fail to enter the correct information. Okay. So when there is a wrong information that we include, we call it fault of commission, and when we forget to include the information, we call it the fault of omission. Okay. So fault of omission obviously are more difficult to detect and resolve than the fault of commission, because in fault of commission we are likely to find out the mistake that we have committed. Okay. So fouls can be elusive. Okay. That is, when a designer makes a error of omission, the resulting foul is that something is missing and that should be present in the representation, right? So normally such kind of fouls we can call as the elusive fouls. Okay, that is those fouls are elusive, the fouls of omission. So the third definition is the failure. Now failure occurs when the foul executes. So when we execute a foul, we are likely to face failure. Okay. So there are two subtleties arise here from the failure. That is, the first subtlety is that the failure only occur in executable representation, which is usually taken to be the source code and more precisely loaded object code. Okay. So in the foul of commission, when we execute, we are going to get some failure which will be in the executable representation. Okay. The second subtlety is that this definition relates to the failure only in the foul of commission. So when we get such representation, executable representation of the failure, this is going to be obviously the foul of commission. Now, given these two subtleties, these facts, how do we deal with the failure that corresponds to the fouls of omission? So, or we can still push it further, like what about fouls that never happen to execute, or maybe don't execute for a long time? So those fouls are obviously very difficult to identify. So those fouls, like which may not have executed for a long time, or or have never been executed. Okay. So the most usual way of identifying the foul is to have a proper review. So when we review the things, review prevents many failures by finding the fouls. In fact, well done review can find foul of omission. Okay. So when we do some well done review, it can actually find the foul of omission also. Foul of omission is the proper well done review likely to lead to the identification of foul of commission, or even it can identify foul of omission. So incidence is another definition. Definition here is the definition of incidence. So when a failure occurs, it may or may not be the user may not be able to identify that failure has occurred. Okay. They may have identified a failure has occurred. Okay. So what is an incident? A symptom. The user failure. Okay. So when we can the symptoms which gives indications to the users that the system is likely to fail. Okay. So symptoms we call as the incident. Now testing is obviously concerned with error, foul, failure and incident. Okay. So basically a test is nothing but the act of exercising the test cases. We write some test cases, and when we exercise the test cases, we call it the test. Okay, we call it test. So obviously it involves all the four previous terms that we have discussed, like error, fault, failure and incident. So here when we call test, we have two distinct goals associated with the test. That is to either find failures or to demonstrate the correct execution. Okay. When we call a test, we execute a test case. It is basically the goal is up to two parts. So when we call testing, when we call a test. So the first is that it may be either to find failure in the system, or it can be to demonstrate the correct execution. Okay. Now, the very term that is associated with a test is the test case. Okay. Test case is the basic of the everything that we are going to discuss in this particular part. That is the test cases is the how to plan a test case, how to identify the test cases, okay, how to do the basic planning of the test cases, identify the test cases, design of test cases, and evaluation of test cases. These are the core objective of this particular part. That is the testing of the software. Okay. So test cases are the core of this particular part, where a test case has an identity and is associated with a program behavior. So when we call of a test case is always have a particular identity to identify the test case, and it is associated with the behavior of the program, how the program should behave. Okay. So test case also has a set of inputs and a list of expected outputs. So when you call the test cases, it has a set of inputs which should be given to the test case to identify the correct execution of the test. Okay. Correct execution or failure of the test. So it is we must provide a set of inputs, and we judge the output against some expected output. Okay. So that is what the list of expected output is also required. So you can see the diagrams here. When we include a test case, we provide input. So when we provide the input, there is some precondition that exists with the software. So those preconditions is one part of the input, and another is the external input that you provide to the system through the test cases. When the output is produced, the post condition must exist for once the test cases are executed. So post conditions should be specified, and the actual output that are produced from the test cases, which are actually compared against the expected output to identify whether the test has failed or passed. Okay. And once we identify whether test has failed or passed, we compare the post condition that must exist. So we can identify the life cycle of a testing life cycle through a figure which you can see here. This is the testing life cycle figure, where for all those phases in the waterfall model, say requirement specification, design, coding, in this you are always likely that some mistakes or errors are included, and for those mistakes which are included in these phases while executing these phases, suppose there is some mistakes which are included in the requirement specification, then there is the fault, okay, or the defect which is included in that requirement phase because of the error. It is a result of the error. Okay, that is when the error occurs, the mistake was committed in the requirement analysis, a bug was included, that is the fault, okay, in the requirement analysis, and then that bug propagates to the design. There may be again some mistakes in the design phase. Some additional bug will be included, defects will be included, that will propagate to the coding. Okay, so there is a propagation that may occur while going from one phase to the another phase, and then comes the testing. In the testing, we execute the test cases that we have prepared to identify those bugs. Okay, so here the testing is being done with the execution of the test cases, and that leads to see whether the symptoms, that is the incidence of as a result of these errors and the bugs that have occurred in the earlier phases, and then we need to have the fault resolution. Okay, even fault resolution may have included some additional error because of improper planning of the test cases and all. Okay, so that may also occur. Though basically, these are the phases which goes up to the foul resolution, that is a foul classification, okay, provided given on the incidents, that is the type of symptoms. We classify the fouls, okay, and then some fouls can be isolated. So foul isolation phase comes after classification, okay, and finally the foul resolution where we fix the fouls, okay. So this shows a testing life cycle of a software system. So when we call this testing life cycle, the first 3 phases are basically putting the bugs in. As you can see, we put the bugs in the first 3 phases. Okay. Then comes the testing phase where we find the bugs. Okay. So this testing phase where we find the bugs. Okay. Then comes the last 3 phases are basically getting the bugs out. That is, after finding the bugs, we remove the bugs with the last 3 phases here. And as I told you, the foul resolution step is again another opportunity for a error to occur, a mistake to occur. Okay. If we fail to properly fix the bug, then obviously we are setting some mistakes again in the system. Now, the core of the entire this testing mechanism is test cases. Okay. So essence of software testing is to determine a set of test cases for the item to be tested, item being tested. So for all the items that is being tested, to determine a set of test cases, it is the essence of any software testing mechanism. So act of testing entails establishing necessary preconditions, providing the test case inputs, observing the output, and then comparing this with the expected output to determine whether or not the test has passed. Okay. So as I told you, it is basically when we include the test cases or run the test cases, it is basically all related to necessary preconditions that might exist, and then we must provide the test cases with the test case inputs. Okay. Then outputs are produced where we observe the outputs and compare them with the expected output, and then we judge whether the test has passed or failed. Okay, after comparing with the expected output. Obviously, we also look for the necessary test condition, the output. We can say output push condition. That is the push condition of the output must also exist. So test cases should have an identity and reasons for being. Okay. While we are writing a test cases, every test cases there must be a reason for writing a test case. Also, every test case must be identified with an identifier. A identity must exist for a test case. Okay. So this reasons for being a test case, one of the fine reasons may be only to requirement tracing. That is whether the requirement given by the users are fulfilled or not. That may be a fine reason for writing a particular test case. Okay. There may be obviously many more reasons for writing the test cases. It is also useful to record the execution history of the test case, including when and by whom it was run, pass-fail results of each execution, and version on which it was run. Okay. So every execution history of the test cases that has been designed and that has been executed can be recorded. Okay. So when we record these test cases, record the execution history of the test cases, this includes, the person by whom it was being run, the pass-fail results of the test case, okay, test case execution, and the version of the software on which it was run. So test cases are something which must be developed properly, reviewed, test case must be reviewed from time to time by the developers team, used and then use the test cases, manage the test cases, that is the set of test cases should be properly identified and that should be managed, that is manage the test cases and then set. So test case should be set. So these are the necessary requirements while maintaining the test cases. Test case is as important as coding. So when we develop the software development part and the writing and the maintaining of test case is equally important part of the software systems. Now, this entire thing about testing can be viewed in terms of a Venn diagram. Okay, that is, when you can see input as the specification, the coding as the progress, and the test cases in the test part. That is the three circle that you can see. F indicates the specification, program is this circle, and there is the intersecting circle which is the test case. Okay. So from here you can see this part is the fouls of omission. Because why this foul of omission? It was basically specified, but it was not covered by the coding part, not programming. So it is the part which is ignored by the coding. So if there is a specified behavior that has not been included by the program, it goes into the part of the specification, that is the fouls of omission. Okay. So 5 and 4 are the 5 is the fouls of omission. Okay. So similarly, fouls of commission. Here this part indicates the fouls of commission because it is being executed but it was not specified. So it is it is being programmed or implemented but that have not been specified. Okay. So to view this, to find the insight from the Venn diagram, to understand the testing mechanism, a very good view of the testing is that it is the determination of the extent of program behavior that is both specified and implemented. Okay. What can a tester do to make the regions where these sets all intersects to be as large as possible? So how does test case in the set T are identified? So our objective here is to identify this particular region as large as possible. Okay. There may be certain regions like which is specified as well as programmed but not included in the test case, like this 2. Okay. It is specified also 5 and it is not being either programmed or being tested is the 5 region. Okay. Similarly, we can have the specified and the program part but not tested is the 6 and 2. Okay. So these are different parts, like similarly there is a region 3 which is basically which is programmed and tested but not specified. Okay. So there may be different parts of the program that of the test cases which may be identified as as belongs to whether it belongs to the specification or the program or the test case. So our objective or better system testing is to identify this part indicated by 1 is as large as possible. Now identifying the test cases. How do we identify the test cases? Okay. So it is there are 2 parts we can say is the specification based testing or the functional testing, or we can say code based testing or structural testing. Okay, so there are two fundamental approaches: specification based testing or functional testing, and code based testing or structural testing. Identifying test cases in the specification based testing. The specification based or functional testing actually is based on the view that any program can be considered to be a function that maps values from the input domain to the values of the output range. Okay, so it is, so this notion, that is where we consider it to be a specification based testing, where actually based on the functional testing is based on the view that any program can be considered to be a function that maps values from the input domains to the values of the output range. That means we are not concerned about the inner implementation of the function, that is only the input domains, the inputs which are considering to the function, and the output range we are considering to develop the test cases. Okay, so this is what we do in the specification based testing. Or we also commonly this kind of behavior, since we are not considering the inner implementation of the function while developing the test cases, we call this kind of testing as the black boxes testing also. Okay, that is we only map the input values to the output values or the output range. So function of the black box is basically understood completely in terms of the input and the output. Okay. So with the functional approach or to test case identification, the only information that is used is the specification of the software. Okay. So only specification of the software is used as the information to identify the test cases, not the implementation part. So there are some advantages of doing so. That is, we don't have to be, test case development becomes actually independent of the implementation part. Okay. So even if the implementation changes, the test cases are still useful. So when we develop the test cases only from the input and the output ranges, without considering the implementation part, the test case remains useful even if the inner implementation of the function changes. So, and test case development can occur in parallel to the implementation. That is, it is while the implementation is going on, the test case development can occur in parallel to the implementation part, and that actually reduces the overall project development interval. Then there are negative sides also of this specification based testing also. There can be significant redundancies among the test cases with the specification based testing, and this is compounded by the possibility of gap in the untested software. Also, these redundancies can be compounded with the possibility of gaps in the untested software. So similarly, the another test case identification process is the code based testing. Okay, specification based testing and the code based testing, as I told you, or it is also sometimes called as the structural testing. So in this case, we call it as a white box or clear box, because we consider the internal data structure and algorithms to write the test cases. Okay, so the tester has basically access to the internal data structure and the algorithm, including the code that implements the function. Okay, so based on that, the test cases are written. So there are some advantages of code-based testing. Basically, code-based testing lends itself to the definition and use of test coverage metrics. That is, how much of different coverage being done. Like, say the test designer can create tests to cause all statements in the program to execute at least once. Okay, so this indicates the test coverage of a particular execution. So basically it defines this lends itself to the definition and use of the test coverage matrix. So test coverage matrix provides a way to explicitly state the extent to which a software item has been tested, and this in turn makes the testing management more meaningful. So to what extent the testing has been done, that is given by the test coverage matrix. So this actually helps in managing the testing more meaningfully. Okay. So that is what the advantage, this is another advantage of the test code-based testing. Now specification versus code-based testing, which is better? Okay. Whether specification-based testing is better or code-based testing is better. So we know that specification is basically specification-based testing identifies the test cases based on the input and output domain, whereas code-based testing is basically it identifies the test cases based on the program source code, okay, or implementation part of the program. So neither approach is actually sufficient by itself. Both are equally important. Okay. Suppose, consider the program behavior. If all the specification behavior had not been implemented, the code-based test cases will never be able to recognize this. Okay. So if suppose if you have not implemented all the specified behavior, then what will happen? Only suppose code-based testing you execute. It is not going to identify that the specified behavior is included or not. Okay. Without testing, the specification-based testing, you cannot identify from the coding only that whether a particular specification is implemented or not. Okay. Program behavior is implemented or not. So conversely, if the program implements behavior that have not been specified, this will never be revealed by the specification-based test cases. So if suppose a program implements behavior, a implementation of the behavior has been done which was not specified in the specification, that is the specification based, that is the requirement. Okay. So then the specification based testing will never be able to identify that. If you are not running the code based testing, it is not going to identify that particular part, which is not going to test those cases, those that has been implemented and not specified in the test based specification. Okay. So both are equally important, because whether all specification that is there in the software is implemented or not will be identified only through the through specification and both code-based programming. That is, if there are some additional code being implemented of the some behavior which is not specification, which was not there in the specification, then obviously only specification based testing will not judge those. You cannot include the, you cannot identify those parts, those codes from the only specification based testing. Similarly, if it was not there in the, if some specification is not implemented there from the code based testing, you will not be able to identify that without implementing the specification based testing. Okay. So both are equally important, and therefore both approaches are needed. Now, there are some differences between black box testing and white box testing. Black box testing is a software testing method which is based on, which is used to test the software without knowing the internal structure of the code or program. Okay. So unlike that, white box testing is the software testing method so in black box testing, you don't need to know the internal structure. In white box testing, you need to know the implementation part of the software. Okay. So in the black box testing is normally carried out by the testers. Okay. And the white box testing is normally carried out by the software developers, because software developers are the actual people who know the implementation part of the software. Testers are not very much aware of the actual implementation part of the software. So to carry out the black box testing, the implementation knowledge of the software is not required. Okay, but to carry out the white box testing, you need to know the implementation part or implementation knowledge of the software. Okay. Similarly, programming knowledge is not required for black box testing, whereas for white box testing, you need to have a programming knowledge is required to carry out the white box testing. The testing, this kind of testing, black box testing, is basically is applicable at the higher level of testing, that is either system testing or acceptance testing. Okay, so black box testing are normally applicable at the higher level, whereas white box testing is applicable at the lower level, that is those applicable at lower level of testing, that like the unit testing and integration testing. Okay, so black box testing means the functional test or external testing. That is, black box testing means we can call it functional test or the external testing. White box testing means the structural test or interior testing. Okay, if in black box testing is primarily concentrate on the functionality of the system under test. Okay, in white box testing is primarily concerned on the testing of program code of the system under test, like code structure, branches, conditions, loops, etc. So all those structures are being tested in the white box testing. Whereas in the black box testing, you only primarily concentrate on the functionality of the system. The main aim of the black box testing is to check on what functionality is performing by the system under test. The main aim of the white box testing is to check on the how system is performing. Okay, black box testing can be started based on requirement specification document. When a requirement specification document is ready, you can basically design the test cases for the black box testing. White box testing can be started based on the detailed design document. Until and unless the coding is done, you cannot go for development of the test cases for white box testing. So that is only when the detailed design has been done, where algorithms have been finalized and all, then only you can check for you can write the test cases for the white box testing. The functional testing, behavior testing, closed box testing is carried out under black box testing. So there is no required of the programming knowledge. Okay, and whereas the structural testing, logic testing, path testing, loop testing, code coverage testing, open box testing is carried out under the white box testing. So there is compulsory to know about the programming part. Now, process versus product, the foul taxonomies. When we call, when process refers to how we do something, okay, that is how we develop something, that refers to the process. And product actually refers to the end result of that particular process. Okay, so when we get something as a result of doing something, that is the product, right? So now the software quality assurance is basically one part which we can say meets the testing in the sense that it identifies that how good a product can be built based on the improvisation of the process. That is the software quality assurance. Okay. So when we improvise the software, the process of development of something, that is to get a error-free product or a good product is called as the software quality assurance. But testing is something, which is related to more product oriented. Unlike this part, the testing is basically more product oriented because we identify how good is the product by using the testing. So So basically, we identify how we try to identify the faults and the defects in the product, so that we get a good product, and that is done through testing. So testing is basically product oriented. Now, the fouls, which are basically related to the products or testing part, so it can be classified into several ways. That is, the development phase, where the corresponding occurred, that is the foul occurred. Okay, consequence of corresponding failures, difficulty to resolve, that is to resolve the fouls, the risk of no resolution, and so on. Okay, so this way we can divide the fouls into some categories. Okay, fouls which are related to the development phase, or fouls which are the consequence of some failures, or the difficulty to resolve, those fouls, or the risk of no resolution. So IEEE has basically divided the fouls into various parts, various classes, categories. So we can find out certain, some parts of those fouls, or we can actually identify some important fouls which can be divided into those categories. Okay. So input-output fouls, where the input means the correct input. Say these are the instances of the fouls, like type is input, the kind of foul, the instance when these input fouls may occur, the type of foul may occur. That is, if we don't give a correct input, or if incorrect input is accepted by the system, or description, if wrong description or the missing inputs are missing, then also that is another foul. Or parameter wrong or missing, if some parameters we fail to give, that is also another kind of foul. So these are the different instances which indicates the input type foul. Similarly, output type foul, wrong format, wrong result, correct result at wrong time, incomplete or missing result, okay, spurious result, spelling, grammar, cosmetics, etc. are the output types. So logic foul is another category where the logical mistakes are being carried out. Okay, the fouls or the bugs that arise out of the logical mistakes, like if there is a missing case, or a duplicate case, or extreme condition neglected, if our logic neglects extreme cases. Similarly, if there is some misinterpretation in the logic, or missing condition, extraneous condition, test of wrong variables, okay, incorrect root iterations, wrong operators, okay. So if we give a less than instead of less than equal to, okay. So these are the logical fouls. Similarly, there can be computational fouls, where we can say the fouls are because of the mistakes in the computational part. Say incorrect algorithm, missing computation, incorrect operand, incorrect operation, parenthesis error, insufficient precision, okay, wrong built-in function are the fouls which are basically can be categorized as computational fouls. Similarly, interface fouls can be another category, where the fouls are caused in the interface part of the software. So incorrect interpretation, interrupt handling, okay, IO timing, call to wrong procedure, call to non-existent procedure, parameter mismatch, incompatible types, superfluous inclusion, etc. are the fouls which can be categorized as interface fouls. Similarly, there can be data fouls. Suppose like incorrect initialization, incorrect storage, wrong flag, incorrect packing, wrong variable used, wrong data reference, scaling or unit error, incorrect data dimension, incorrect subscript, incorrect type, incorrect data scope, sensor data out of limit, off by one, inconsistent data are some of the examples of data faults. The levels of testing. The testing actually can be categorized into different abstractions as per the waterfall model. Every abstraction level in the waterfall model can correspond to one level of testing. Okay, and when we categorize this way, we can call it as the V model. Okay, and and this V model basically corresponds to we can call it it is the testing model which actually corresponds to the waterfall part. So V model is a software development model, which can be presumed to be the extension of the waterfall model. Okay, so when we specify waterfall model, for every level which test level is there, that is identified and that is specified in the V model. So instead of moving down in a linear way, the process steps are bent upward after coding phase. Okay, so after coding phase, the process steps are bent upward to form the typical V shape. Okay, so V model demonstrates the relationship between each phase of the development life cycle, that is the waterfall model, and its associated phase of testing. Okay, so you can see the example here. We can see in the V model, we have these are the waterfall abstraction level of the development phase. First we do requirement analysis, then high level design, then low level design, then coding, right? So every level after coding, it takes a V shape to identify the level of testing for each of these abstraction level in the waterfall model. So here you can see the low level design corresponds to the unit testing. Okay, that is a detailed design, which the testing part, we can say code-based testing can be carried out at the detailed design level. So those test cases can be written here, and this corresponds to the level of abstraction at the detailed design part. Similarly, the integration testing basically refers to or at the equal level to the high level design, and similarly we can have the system testing at the level of the requirement analysis. So this shows the V model for testing. So for today's class, this much is enough. In the next class, we'll be discussing about the boundary value analysis for testing the software systems. Okay, so thank you.